Hi students, I hope you are fine and healthy at your home. Now we are going to start new video of chapter number 5th. Write Newton's law, second law of motion and prove that force equal to ma. Okay, we have earlier discussed Newton's third law of motion. You can just revise that. But also we'll discuss second law. Second law states that the rate change in momentum is directly proportional to the applied force. This is our second law. So we have to prove that F equal to ma, mass into acceleration. So let the initial velocity of a body is of mass m is u. So let students, if we have a body which have a velocity is u, initial velocity is u and final velocity is v. Momentum is v1, momentum of body p2 after final momentum. So here we are writing down let the initial velocity of a body of mass m is u. Then momentum, we know that momentum equal to p equal to m v. So p1 equal to mu because the initial velocity is u. So, similarly, after the time del t, final velocity will be v. So p2 will be our momentum, p2 will be m, capital V. Okay, this is our final velocity. Now we have to determine the change in momentum. Change in momentum del p equal to will minus mv minus mu. Okay, so del p equal to mv minus mu. mv will take common, so what will remain? V minus u, or we can write this v minus u is our change in velocity, so we can write in place of del v. Okay, where del v is change in velocity. So rate change of momentum, we are getting that with the time m del v upon del t. This is the change in momentum, and we are applying the rate change of momentum will divide with the respect to t, del t m del v upon del t. But we know that del v upon del t change with respect to time in velocity is known as acceleration. So we know that acceleration equal to del v upon del t. So rate change of momentum, this is our m and this is our a, equal to applied force. So F, this is our force, F is directly proportional to ma, or will remove this sign is proportional. Okay, F is proportional to ma. If we are using to remove the sign, we have to use a constant which is k. So we'll get F equal to kma, where k is constant. So this type we can solve the questions. Very easy, that type of question. Now we will solve another question which is numerical. You can take help this question. Afterwards you can solve many of questions. A force of 10 Newton acts upon a body of mass 5 kg for 5 seconds. Calculate impulse, change in momentum, change in velocity and acceleration. So I am going to solve you this question. So similarly you can solve another question. We have a force 10 Newton is applying upon a body mass 5 kg. This given force is 10 Newton, mass is 5 kg and time del t is 5 seconds. So first we have to determine impulse. What is impulse? Impulse equals to force applied within a small interval of time. So force is 10 or time is 5. So impulse will be 50. What is the unit of impulse? Because F force Newton and time second, so Newton per second. Our impulse will be 50 Newton per second. Okay. Now we'll get change in my momentum. Change in momentum, we know that change in momentum is equal to applied force. What is the force is applied here? F del t. This is similar for the 50. Okay, this is also change in momentum. Change in momentum equal to applied force. So what is the unit of momentum? Kilogram. P equal to mv, mass kilogram, or velocity meter per second. Okay, so change in momentum equal to impulse you can write, which will be same. Our C, what is there? Change in velocity. Change in velocity, how can we determine change in velocity? Change in velocity, we can determine momentum of the body upon mass of object, or we can write change in momentum or change in momentum upon mass of body. One formula you can use, you can determine many of the questions. Change in momentum is our 50 kilogram, mass of the body what is given 5. So what will be 10 meter per second. This is the change in velocity. Okay. Afterward we have to determine acceleration. Acceleration equal to, we know that force equal to ma, then acceleration will be F upon m. Force is given. What is the force is given here? 10 Newton. And mass of the body 5 kilogram. So 5 to the 10. So acceleration will be 2 meter per second square. Okay. This type you can solve the questions. Similarly, you have to solve many of the questions like this question.